Welcome to this video. Today we talk about basics of thermometry and calorimetry, basics of heat and measurement of heat. What is thermometry? Thermometry is the measurement of temperature. Thermo is heat. Thermometers are devices used to measure the temperature. Calorimetry is study of measurement of temperatures. So what is heat then? There is nothing called hot and cold, very technically speaking in science. The absence of heat is what coldness is. What heat per se? Heat is a form of energy. It is called thermal energy. Like sound energy, light energy, we have a thermal energy. Heat is a form of energy. And this heat flows from a hotter body, that is a body at a higher temperature, to a colder body, that is a body at a lower temperature. So heat flows not from hot to cold, but heat flows from a higher temperature to a lower temperature when they are placed in contact with each other or otherwise. So we have three types of flows of heat: conduction, convection and radiation. Now, why is there a heat? Why is there a thermal energy? It is because of the sum of all forms of kinetic energies of all the constant particles that constitutes the mass of the body. Heat is the sum of kinetic energies of all the constant particles that constitute the mass of a given body. The forms of energy. What are the different forms of energy? The translational energy, the vibrational energy and rotational energy, or the translational, vibrational and rotational motion of the molecules of the particular body or object or a substance is what gives rise to heat. The SI unit of heat is Joule, represented by J, and the practical unit is calorie. SI unit is Joule, practical unit is calorie. What is 1 calorie? 1 calorie is 4.18 joules. What is 1 calorie? 1 calorie is the quantity of heat required to raise the temperature of 1 gram of water by 1 degree centigrade. So 4.18 joules is the quantity of heat required to raise the temperature of 1 gram of water by 1 degree centigrade. Now we have something called mechanical energy or work. This mechanical energy or work can be converted into heat. That is why when you walk too much, you feel like sweating, right? When you switch on the fan for quite some, fan becomes hot because the motor is doing a work of going round and round. Air conditioner, refrigerator, anything that you make to do some work, it will become hot. Cycle, when you ride a cycle for quite some time, it becomes hot. So any work that is done will get converted into heat. And heat can be used to convert it into work. How heat is used to convert it to work? When you heat steam or water becoming water vapor is used to run the steam engines. So heat is converted into mechanical energy to make that engine move forward. So mechanical energy W can be converted into heat Q, where the formula is W equals to JQ, where J is the joules mechanical equivalent. Joule is the mechanical equivalent. Now this J is different from the joules per calorie J. This J is different from the joules per calorie J. This is a slanting J. So this is called the conversion factor. This is called the conversion factor. It is not the physical quantity, it is a conversion factor. And the value is 4.186 joules per calorie. 4.186 joules per calorie. So where W is the work and Q is the heat. What is temperature? Temperature is a degree of hotness or coldness of a body. Coldness is absence of heat. The temperature is a degree of hotness or coldness of a body. The highest possible temperature possible is 10 power 8 K. In a lab, you can raise the temperature up to 10 power 8 K on the positive side, or you can reduce the temperature. You can freeze it to 10 power minus 8 K. 10 power minus 8 K. That means 1 by 10 power 8 K. What is cryogenics? Cryogenics is dealing with production and measurement of temperature close to 0 K. Right? What is pyrometry? Pyrometry is dealing with measurement of very high temperature. Dealing with very high temperature. Cryogenics is nearer to 0 degrees, while pyrometry is dealing with very high temperature. What is very high temperature? We can talk about the temperature of the sun. What is temperature of the sun? The core of the sun is 10 power 7 K. The core of the sun is 10 power 7 K. Here, the sun is a hot ball of burning gases. On the ball, the core is 10 power 7 K, and on the surface it is 6000 K. Surface is 6000 K. 6000 K means what? 6 into 10 power 3 K. So surface is 10 power 3 K while the core is 10 power 7 K. We have seen here heat is measured in joules as the practical measure and K as the Kelvin. What is NTP? NTP is a normal temperature and pressure or the standard temperature and pressure. At standard temperature and pressure for air, at 0 degrees, it is 273 K. 0 degrees is a temperature. Standard temperature is 0 degrees. Pascal is 10 power 5. Standard pressure is 10 power 5. Then we have 273.5 K, which is also 273.5 K or 0 degree centigrade or 32 degree Fahrenheit. 32 degree Fahrenheit is same as 0 degree centigrade, which is same as 273 K. At this temperature and 10 power 5 pascals as a pressure, whatever you have air, that is the STP of air. So temperature is normally measured based on STP and it is 273 K or 0 degree centigrade or 32 degree Fahrenheit, 273 K. So this is 4.18 joules. Now what is Celsius? The scale of temperature, we are most commonly using 4 different scales. Celsius is a very popular scale where melting of ice is at 0 degree centigrade. 100 degree centigrade is the boiling point of water. So water becomes solid at 0 degree, water becomes vapor at 100 degree. Between this, the space is divided into 100 equal parts. This is Celsius temperature. 0, 1, 2, 3, 4 up to 100 degree centigrade. Now what is Fahrenheit? Fahrenheit, the melting point of ice is taken as 32 degree centigrade. Water becomes ice as 32 degree Fahrenheit. And water boils and becomes vapor at 212 degree Fahrenheit. The gap 32 degree Fahrenheit to 212 degree Fahrenheit is divided into 180 parts. 180 parts. Fahrenheit is measured in 180. That is why when you have a fever, when you try to measure with a clinical thermometer in a hospital, in Celsius, degree Celsius, you will have around 32 to 37 degree centigrade, while in Fahrenheit, you will have 9900 degree Fahrenheit. What is Kelvin? Kelvin is a melting point of ice is 273 K. That is why we said 273 K is 0 degree centigrade is 32 degree Fahrenheit at STP. 273 K Kelvin. And the boiling point is 373 K. 273 to 373. This space is divided into 100 equal parts. That is Kelvin. What is Reuma? Reuma 0 degree R to 80 degree R and divided into 80 equal parts. Divided into 80 equal parts. So this is 100 equal parts, 180 equal parts, 100 equal parts, 80 equal parts. 0 to 80 degrees, 273 to 373, 32 degree Fahrenheit to 212 degree Fahrenheit, 0 degree centigrade to 100 degree centigrade. This is how temperature, the scale of temperature that we commonly use. Now the types of thermometers. What are the types of thermometers? Mercury thermometer. Mercury thermometer works on the basis of the length of the mercury column from some fixed point is taken as a thermometric property. What is a thermometric property? Thermometric property is a property of a substance to change in the form of maybe expand or whatever, change its physical specifications or characteristics or properties. So property of an object or a substance that changes due to the impact of heat is called thermometric property. Now this changes in thermometric property is what is used when we try to build thermometers to measure the temperature. So mercury thermometer depends on the length of mercury column in a capillary tube. So mercury thermometer is what we use normally to measure our fever or whatever in a hospital. In good old days, now we use a digital thermometer. So the thermometric property is the length of the mercury column at 0 degree centigrade and at 100 degree centigrade are noted, and then it is divided into 100 equal parts, and then we know when it is heated, mercury will increase from here to here for every degree centigrade. L0 is the length at 0, L100 is the length at 100, LT is the length at a particular temperature. What is the formula T? What is the temperature? How much fever you have? LT minus L0 by L100 minus L0 into 100 degree centigrade. So when you have fever, the nurse there need not multiply this, the thermometer is automatically calibrated. So in a mercury thermometer, temperature T is equals to LT minus L0, where LT is a temperature at the length at T, length of the mercury column at temperature T, length of mercury column at temperature 0, length of mercury column at temperature 100 minus length of temperature at 0 degrees. So LT minus L0 by L100 minus L0 into 100 degrees centigrade. This is mercury thermometer. Constant volume thermometer, what do we do? It's a principle used is change in pressure with temperature when volume is kept constant. The pressure, the temperature, volume is a related entity. So change in pressure with temperature when volume is kept constant is used in constant volume gas thermometer. So P0, P1 and PT are the three measures that we take. P0, P1 and PT are the three measures that we take. PT is a pressure at a temperature. P0 is the pressure at 0 and P100 is the pressure at 100. And then temperature is, we have temperature 0 degrees centigrade, 100 degrees centigrade and T degrees centigrade, three different temperatures. So how constant volume gas thermometer works? T equals to PT minus P0, that is pressure at temperature T, pressure at temperature 0 divided by pressure at temperature 100 minus pressure at 0 temperature, 0 degree centigrade. This is how the temperature is measured in a constant volume gas thermometer. Then T is volume, T minus volume 0 by volume 100 minus volume 0. Why? Because the constant volume gas thermometer works on the principle change in pressure with temperature and volume is constant. So volume is constant. This is how we have the formula. Another thermometer is a platinum resistance thermometer. Here the resistance of the metals with the temperature, resistance of the metal with temperature is used in the platinum resistance temperature. R0 resistance at 0, R100 resistance at 100, RT resistance at T, and then T equals to RT minus R0 by R100 minus R0 into 100. If you see, all the formulas are same. LT minus L0, PT minus B0, VT minus V0, RT minus R0, it is same. 0 degree centigrade. So this will become RT by RTR into 273. It will become a 273 Kelvin. So alpha, what is alpha? It is the coefficient of resistance. Alpha is the coefficient of resistance. And how do we define alpha? R100 minus R0 by R0 into 100. Coefficient of resistance is alpha. Now we have seen the types of thermometers. Now expansion of solids. Now the substance, when it is heated, most of the substances undergo an expansion. The substance undergo an expansion because the effect of the molecules when it is heated, because of the effect of the heat on the electrons and nucleus of the substance, most of them expand. So expansion in solids is different types. Thermal expansion is expansion of the matter itself with no change in the state. When water is heated, water becomes vapor. That is one expansion. There is no change in the state, but only the expansion of the matter is called thermal expansion. The thermal expansion can be linear. Linear means what? Lengthwise. Lengthwise. So increase in length L2 minus L1 into 1 plus alpha into delta T. What is delta T? Change in temperature. L2 is the new length. L1 is the previous length before heating. 1 plus alpha into delta T. Alpha into delta T. Change in temperature. What is alpha? Alpha is called coefficient of linear expansion, and coefficient of linear expansion is delta L by L into delta T. Delta L is change in L, delta T is change in temperature. We have seen coefficient of resistance alpha is R100 minus R0 by R0 into 100. Coefficient of linear expansion is delta L by L into delta T. And then here we have 1 plus alpha into delta T, which will give you the increase in length from L1 to L2. Superficial expansion, that is expansion of the area of the object. It is length of the object, it is area. What is the formula? A2 equals to A1. A2 is the new area. A1 old area 1 plus beta into delta T. What is beta? Coefficient of superficial expansion. What is beta? Delta A by A into delta T. Delta A is change in area, delta T is change in temperature. Then we have a cubical expansion. The volume, the whole volume, if it increases, it's not just the area, 2 dimension, length is 1 dimension, volume is 3 dimension. The whole cubical expansion, whole volume is increased. Then we have increase in volume equals to V2 equals to V1 into 1 plus gamma delta T. 1 plus gamma delta T. What is gamma? Coefficient of cubical expansion. Delta V by volume into delta T. Delta V is change in volume, delta T is change in temperature. Now this linear expansion, superficial expansion, cubical expansion are related to each other. How? Superficial coefficient beta equals to 2 alpha and gamma equals to 3 alpha, or alpha is to beta is to gamma is in the ratio 1 is to 2 is to 3. Linear expansion coefficient alpha, coefficient of superficial expansion beta and cubical expansion coefficient gamma are in the ratio 1 is to 2 is to 3. Now expansion of liquids. Liquids have a different type of expansion. One is apparent, one is real. What is apparent expansion? Expansion of the liquid on heating, where the heating of the container is not taken into account. Heating of the container is not taken into account. Where coefficient of expansion is alpha, gamma alpha. Subscript we are writing here. Alpha is writing as a subscript. Apparent or observed increase in the volume divided by original volume into change in temperature. Observed, apparent increase in volume divided by original volume into change in temperature. Apparent is what is observed and not taking into account the expansion of the container is called the apparent expansion. What is real expansion? That is expansion of the liquid on heating when expansion of the container is also taken. When expansion of the container of the liquid on heating is also taken into account. So expansion of container not taken into account is apparent. Expansion of container taken into account is real. Real increase in volume divided by original volume into change in temperature. Gamma is the coefficient. Alpha is for apparent and R is for real. Apparent and real. So this is a coefficient of cubical expansion. What is coefficient of cubical expansion? Gamma R, gamma A. Gamma R, gamma A. It is measured in per degree centigrade. What is the formula? Gamma R equals to gamma A plus gamma G. Gamma A plus gamma G is the gamma R. R is the real, A is the apparent, and G is what? G is the expansion due to the container. What is analogous expansion of water? Now water is a liquid, it expands, it has apparent and real expansion. Analogous expansion means that when temperature of water is increased from 0, then its volume will decrease up to 4 degrees centigrade. When the temperature goes up from 0 to 1 to 2 to 3 to 4, it will decrease. What will decrease? Volume will decrease up to 4. And then it is a minimum volume is at 4, and then after 4 it will start increasing. The volume of the water starts increasing after 4 degrees centigrade. It is minimum at 4 degrees centigrade, and it happens when it is increased from 0 to 4 degrees centigrade. This is called the anomalous expansion of water. This is a sort of anomaly. Now, some substances contract when temperature is increased. Some substances contract when temperature is increased. That is because of the transverse vibration of the atoms. Transverse vibration of the atoms. Now let us look at expansion of the gases. Expansion of gases. First we will look at the volume coefficient. What is the volume coefficient? V0, V1, V2 are the volumes of the gas at 0 degree centigrade, T degree centigrade and 2 degree centigrade. Suppose temperature at 1 degree, first temperature and second temperature, T1 and T2. If we have 2E1 and T2, then volume 2 minus volume 1 divided by volume 0 into T2 minus T1. Volume 0 is volume at 0 degree centigrade. Volume 1 is volume at T1 degree. Volume 2 is volume at T2 degree. Volume coefficient is gamma V. Gamma V is written how? V2 minus V1 by V0 into T2 minus T1. This is the volume coefficient. What is the pressure coefficient? Pressure coefficient is gamma P. Gamma V, gamma P. P2 minus P1 by P0 into T2 minus T1. What is P2? Pressure at. P2 is the pressure at T2, temperature 2. This is pressure at temperature 1. P1 is pressure at temperature 1. P0 is pressure at temperature 0 degree. So pressure coefficient gamma P is P2 minus P1 by P0 into T2 minus T1. T1 and T2 are the different temperatures. Volume coefficient is V2 minus V1 by V0 into T2 minus T1. Now volume coefficient specialty is that the density increases since the volume of the mass increases. Density increases when volume of the mass increases. Why the volume of the mass increase? Because substances expand when they are heated. So when substance expands, the volume increase. When the volume increase, density decreases. When volume increase, density decreases. So density is inversely proportional to volume. Volume is inversely proportional to density. This means what? P is inversely proportional to 1 by V. So what does it stand for? P inverse is P into 1 plus gamma delta T inverse. 1 plus gamma delta T inverse. As gamma is very small, we can take it as 1 minus gamma delta T, where gamma delta is the change or the variation. How this is used, or where this increase in size of the solid or a liquid or a gas we use because of the heat and expansion? In a railway line, there is a gap between two railway lines. Why? Because of the heat they will expand and they should not budge against each other. So there is a small gap. If you look at electrical wire on an overhead pole, electricity, it is not very tight. It is loosely held so that during increase and decrease in the temperature, it can expand and contract and not be in a taut position. So these are the uses of the increase or decrease of the size or the length or the volume of a material due to the effect of heat. What is thermal equilibrium? Thermal equilibrium is a state where there is no transfer of heat between two bodies. Thermal equilibrium means heat is what? Heat is a form of energy that flows from hotter body to colder body. Now thermal equilibrium means no transfer of heat between two bodies. What's a triple point? That is speciality of water, where values of the pressure and temperature at which the water coexist in equilibrium in all three states. Solid, liquid and gas state, if the water coexist in an equilibrium, that specific temperature and pressure is called the triple point. What is that? 273 K and 46 centimeter of mercury pressure. 273 K and 46 centimeter of mercury pressure is the triple point. What is specific heat? Specific heat is measured by C or S. It is the amount of heat required to raise the temperature of unit mass of a substance through 1 degree centigrade. Specific heat is the amount of heat required to raise the temperature of unit mass of a substance through 1 degree centigrade. It is measured in joule per kilogram per centigrade. Degree centigrade. Joule per kilogram per degree centigrade. Now, what is specific heat of water? Specific heat of water is 4200 joules per kilogram. 4200 joules per kilogram and per degree centigrade. Now, it is called 1 calories. It is called 1 calories. 4200 joules is also called 1 calories per gram per centigrade. Specific heat of water is 4200 joules per kilo per centigrade. The amount of heat required to raise the temperature of unit mass of a substance through 1 degree centigrade. Now gases have two types of specific heat. One is at a constant volume and another is a constant pressure. How do we write? CV and CP, constant volume and constant pressure. We have two different specific heats. Now how they are related? The specific heat at constant pressure is greater than specific heat at constant volume. And Mayer's formula says gas constant R equals to Cp minus Cv. It is always positive. Gas constant is Cp minus Cv. Specific heat capacity at constant pressure of a given gas minus specific heat capacity at constant volume is the gas constant R. What is the ratio of the specific heat? Ratio of the specific heat is represented by gamma. It depends on the atomicity of the gas. What is atomicity? Number of atoms. It is Cp by Cv. What is Cp? Specific heat at constant pressure. Cv is specific heat at constant volume. Now, the amount of heat energy required to change the temperature of any substance Q is mc delta T. What is mc? M is the mass of the substance. Specific heat is the unit mass, temperature required to raise the unit mass of substance through 1 degree centigrade. So this is written as C. So M is the total mass, C is the specific heat for the unit mass, delta T is the change in temperature. So total amount of heat required is this change in temperature of a substance into mass of the substance into specific heat of the substance. What is thermal capacity? Thermal capacity is the amount of heat required to increase the temperature through 1 degree centigrade. Amount of heat required to change the temperature of unit mass through 1 degree is specific heat. Specific heat. Thermal capacity is amount of heat energy required to increase the temperature through 1 degree centigrade. Increase the temperature of the whole body through 1 degree centigrade. Heat capacity is mc. So that is specific heat into mass. Molar heat capacity is S by mu. S by mu. Molar specific heat capacity. It is measured in joule per Kelvin. C equals to ms. C equals to ms, where It's a molecular mass of the substance into specific heat. Molecular mass of the substance into specific heat. What is water equivalent? Water equivalent is quantity of water whose thermal capacity is same as the heat capacity of a body. Water equivalent of any body is the quantity of water whose thermal capacity is same as the heat capacity of the body. What is thermal capacity? Amount of heat energy required to increase the temperature of particular body through 1 degree centigrade. So ms, again this is ms equals to heat capacity of the body, which is molecular mass of the substance into heat capacity. Molecular mass of the substance into heat capacity. What is latent heat? Latent heat is the heat absorbed or released at constant temperature per unit mass for change of state. For change of state, heat absorbed or released at constant temperature per unit mass for change of state. What is change of state? Solid to liquid to gas. So it is the heat energy loss or gained is not the absolute measure. At constant temperature per unit mass for change of state is what is called as a latent heat. So Q equals to mass of the substance into L, that is latent heat. Calorie per gram is the measure. For water, boiling point or condensation temperature is 100 degrees centigrade. At 100 degrees centigrade, water becomes what? Water vapor. That means what? Heat energy absorbed or released at constant temperature per unit mass for change of state. The water becomes water vapor. So the heat energy absorbed or released for becoming water vapor. For water at the boiling point, it is 540 calories per gram. It can also be written as 40 kg per mole, 40 kj per mole. J is the joules, which is 2260 kj per kilo. 2260 kj per kilo. This is the latent heat for water. For conversion at constant temperature, unit mass to change the state. Q equals to M into L. Q equals to M into L. For water, the melting point is what? Water melts from ice to liquid. The latent heat of fusion is 80 calories per gram or 60 kj per mole or 336 kj per kilo. 336 kj per kilo. So 336 kj per kilo is smaller when you compare to 2260 kj per kilo. So you need a lot of energy for, or lot of energy is absorbed when it is getting converted into vapor. Steam is, that is why when you get burnt by the steam, you feel more than you getting burnt with the boiled water. Steam converted to water at 100 degrees centigrade gives out 536 calories of heat. So it is clear that steam at 100 degree has more heat than water at 100 degree. Snow absorbs heat from the atmosphere to melt down. So in the mountains, when the snow falls, one does not feel cold because you have snow everywhere. But when the ice melts, you feel very cold. Why? Because when it is melting, it is giving out or absorbing heat in a fashion which is felt by you too much. Ice cream melts when it is touching the teeth. You feel that a large amount of heat is being absorbed from the teeth. That is why teeth loses the heat and becomes cold. Now, what is Joule's law? What is the Joule's law? Joule's law is the ratio of the work and heat. Heat is converted into work or work is heat converted into heat. Either of them, the ratio is constant. Whether work converted to heat or heat converted to work, the ratio is constant. Where Q is ml and W equals to m, as we know. The ratio of work converted to heat or heat converted to work is constant. That is Joule's law. What are the different states? Melting. Melting is solid becomes liquid. Evaporation is liquid becomes solid. Freezing is liquid becomes solid. Now freezing point is a temperature at which liquid begins to freeze. Boiling point is a temperature at which liquid becomes to become vapor. Now what is boiling? Boiling is at a particular temperature, the saturated vapor has a pressure on the heated liquid, and when that pressure is equal to the atmospheric pressure, the bubbles of water start going up. The bubbles of water start going up from the bottom of the vessel to the top of the vessel. That is called boiling. The point at which the liquid boils is called the boiling point. Thereafter, it will become water vapor. Boiling point of water increases with increase in pressure. When it is under too much pressure, you need too much heat to boil the water. The particular temperature at which the saturated vapor pressure of the heated liquid becomes equal to the saturated vapor pressure becomes equal to atmospheric pressure. Saturated vapor pressure of a heated liquid becomes equal to atmospheric pressure. This is the temperature which is called as a boiling point. What is sublimation? Conversion of a solid to vapor directly. What is frost? Frost is conversion of vapor to solid. These are the different changes in states of matter. Now, what is calorimetry? Calorimetry is when a hot body is mixed with a cold body, the heat is lost by the hot body is equal to the heat gained by the cold body. This is called law of conservation of energy. Law of conservation of energy. We already know heat is converted to work or work is converted into heat. We also know the heat energy absorbed or released at constant temperature per unit of mass or is the latent heat. Now, calorimetry says when a hot body and cold body are mixed, the heat lost by the hot body is equal to the heat gained by the cold body. That is law of conservation of heat energy. Conservation is saving, conservation of heat energy. Heat is usually measured in calories or kilocalories. Study of measurement of heat transfer is calorimetry. Study of measurement of heat transfer is calorimetry. Study of measurement of heat transfer. Suppose there is a body of mass M1 and M2 and specific heat C1 and C2 kept at temperature T1 and T2 where T1 is more. When these mixed, then from T1 the temperature goes to T2 and from T2 coldness comes to T1. The equilibrium temperature T mix is arrived at how M1 C1 mass 1 into specific heat 1 into temperature 1 plus M2 C2 T2 mass 2 into specific heat 2 into temperature 2 divided by M1 C1 plus M2 C2. M1 C1 is mass into specific heat. This is the principle of calorimetry. Temperature of the mixture is M1 C1 T1 plus M2 C2 T2 divided by M1 C1 plus M2 C2. Now, other principles of calorimetry is that if the bodies are of the same material, then C1 and C2 are same. That is, specific heat is the same. Then the formula will get simplified into M1 T1 M2 T2 by M1 plus M2. If they are of the same mass, then C1 T1 plus C2 T2 by C1 plus C2. If the bodies are of the same mass and same material, then only temperature will impact the average temperature. If you take two glasses of pure water and mix, one is hot, one is cold, then the mass is same, so the specific heat and the both are same, then it will be only changes in temperature that will create the average temperature. So this is how the formula works. Thanks for watching this video on heat and measurement of heat and the related devices. Thank you.